Hello everyone, this is the Theoretical Doctor and welcome back to my channel. If you want to access flashcards on this topic and other videos, do click the link below. I post weekly videos every Tuesdays and Fridays, so do subscribe for more content. Today we are continuing on the subtopic of proteins, and we will dive into the properties of protein as a buffer and the isoelectric point. Protein as buffers. Proteins are amphoteric in water, meaning the protein molecules can behave like acid or alkali, allowing them to act as buffers. Now, a buffer solution resists the tendency to alter its pH even when small amounts of acid or alkali are added to it. And this is important to prevent extreme changes in pH because changes in pH in the body could affect the functions of proteins and enzymes, and this will cause denaturation of the proteins. So protein as buffers, the carboxylic side chain acts like an acid and the amino side chain behaves like an alkali. Okay, so basically this is what happens. Made a mistake over here, there is no plus. I added this by mistake, yeah. Okay, so protein molecules dissolve in water to form dipolar ions. And dipolar ions meaning you have the positive side and you also have the negative side. And they exist as zwitterions, exhibiting both positive and negative charges. So this is how it look like, okay? They have the positive and the negative charge in the same one itself. So that's a zwitterion. Okay, so this diagram is quite important. When it is in a state of zwitterion, depending on the pH, I will start off with the acidic one. So acidic meaning pH less than 7, right? What happens in an acidic environment? There are high concentration of hydrogen ions. So now, at high concentration of hydrogen ions in an acidic environment where the pH is lower than 7, the negatively charged carbonyl group, the negatively charged carboxyl group, meaning this part here, accepts a proton. They accept a proton and become uncharged, making the overall charge on the amino acid positive. So now when you add hydrogen ion over here, it stabilizes, right? Now the only charge that is left is positive over here, so the whole thing becomes positive, the whole charge. Similarly, at low concentration of hydrogen ions, so basically in an alkaline environment when the pH is more than 7, okay, so in a medium where there is low concentration of hydrogen ions, the positively charged amino group loses its proton. So you notice that over here, right, it loses one proton. So now it becomes like this. It's donated to the medium. And what happens is when it loses its proton, it becomes uncharged. It becomes uncharged again. That's why I said I made a mistake here. It's not supposed to be plus. Please correct that if you follow with the notes. Okay. So now it becomes uncharged and the overall charge on the amino acid becomes negative because you see over here, only this is left. This is no longer plus. Okay, so basically this is what I just said. Just go through it again in your own time. Remember, at high concentration of hydrogen ions and low concentration of hydrogen ions, what happens? What is the isoelectric point? The isoelectric point refers to the point where the total amount of positive charge is equal to the total amount of negative charge. It is when the proteins are least soluble due to the intermolecular bonding of positive and negative charges. And this occurs at a certain pH, so the proteins become least soluble in water and becomes insoluble precipitate. So if you've reached this point, thank you very much. Do subscribe and share this video to those who might find this helpful. See you in the next one.